have appeared in previous GATE exam. Okay, in previous papers of the GATE exam. The aim of solving such problem is to understand the level of problem, the level of understanding we need to require for solving a problem. Okay, when the problem is asked in GATE exam. Okay, again. First problem. This problem has appeared in somewhere in GATE 2000 or GATE 2001 paper. Given that a Laplace transform of two signals ft and gt is given. L of ft is equal to s plus 2 upon s square plus 1. Okay, this is Laplace transform of ft. Laplace transform of another signal gt is given by s square plus 1 upon s plus 3 s plus 2. Okay. Now the question is to find the Laplace transform of signal ht, where ht is given by 0 to t f of tau g of t minus tau d tau. Okay. So we have to find Laplace transform of ht. Equal to question mark. How to find that? The solution. Very easy. See, ht is given like this. F of tau dot e of t minus tau d tau. This expression is the convolutional expression. Okay, convolution of ft and gt. So I can write this as ft convolve with gt equal to. Okay. Now use the property that convolution in time domain goes to multiplication in s domain. Okay. Convolution in time domain becomes multiplication in s domain. Okay. Now once we got this information, now I can write hs is equal to fs into g of s, where fs is Laplace transform of ft, g of s Laplace transform of gt. This will become s plus 2 upon s square plus 1 dot s square plus 1 upon s plus 3 s plus 2. So this will be 1 upon s plus 3. This is my hs. Okay. So this is the way of solving this problem. Very simple problem. We have done nothing. We have just multiplied the given two Laplace transform expression and got the answer. Okay. Now another problem. This problem, a Fourier transform of signal xt is asked. Okay. Actually the full Fourier transform is not asked, but only the form in which the Fourier transform will be, that is asked. Okay. Now see this. Signal xt is given like this, e to the power minus 3t square. Find Fourier transform of xt. Now in the question, 4 choices is given. The Fourier transform of xt will be of the form a to the power minus b mod f, a to the power minus bf, a to the power minus b f square, and d none of these. So our problem has solved. This problem has become simpler because we need not to find the exact Fourier transform but only the Fourier transform. See now. Given xt equals to e to the power minus 3t square, this is a Gaussian curve. Okay. Now we should know this thing, that Fourier transform of a Gaussian is again a Gaussian only. Write a note or write a point. Fourier transform of a Gaussian signal is Gaussian itself. So my Fourier transform will be of the form a e to the power minus b f square. Okay, simple. Understood? Important point here is to know how the Fourier transform of a Gaussian signal will be like. Okay, once we know that, we can easily find that option is the option. Third question. This question has also appeared in GATE exam. Impulse response of a system is given. Okay, and that impulse response is h e to the power 2t t greater than 0. To this system, input xt is entered, and that input is e to the power 3t for t greater than 0. Okay. Now the question is find yt, where yt is the output of my system. Okay. How to solve this? We need to find the value, the equation for yt. Now there are two methods to solve this problem. Okay. The first one, use convolution. Okay. If we use convolution, then yt is equal to integral 0 to t e to the power 2 tau dot e to the power 3 of t minus tau d tau. Okay, one is this way. Another way of solving this problem is using Laplace transform. Okay, with that also we can solve this problem. How to solve this problem? First, find the Laplace transform of ht, which is equal to hs. Find the Laplace transform of xt, which is equal to xs. From this, ys will be hs dot xs, multiplication of hs into xs. To get yt from ys, we need to find the inverse Laplace transform. Okay, on finding the inverse Laplace transform, I'll get my yt. We will solve this problem by both of the methods. Now, first, using convolution, yt is equal to 0 to t e of 2 tau e of 3 of t minus tau d tau. This will become e of 3t outside 0 to t e of minus tau d tau. V e of 3t e of minus tau by minus 1 0 to t. This will become e of 3t e of t by minus 1 minus of minus 1. This will become e of minus t, e of 3t 1 minus e of minus t. So solving this, it will be e of 3t minus e of 2t. Okay, so this is a solution for the equation for yt for t greater than 0. Now using Laplace transform, ht will have Laplace transform hs, which is equal to 1 upon s minus 2. xt will have Laplace transform xs, which is equal to 1 upon s minus 3. Okay. Now, ys will have Laplace transform 1 upon s minus 2 into s minus 3. Okay. Find the inverse Laplace transform of this. This is my ys. Yt will be e to the power 3t minus e to the power 2t for t value greater than 0. Understood? Simple. So both method, whichever you find convenient, we can use that method. Okay? It is only up to the convenience of the problem of the candidate. Again, fourth problem. Two signals are given. One is x1t, which is given by ut minus u of t minus 1. Another signal is x2t, which is given by ut minus u of t minus 2. Okay. Find the convolution of x1t involved with x2t. So you have to find x1t and x2t convolution. If I plot x1t, I'll get something like this. If I plot x2t, I will get something like this. Zero to 2, 1. Okay. Now I need to find the convolution of x1t into x2t. See, the general formula, there are two now. Since it is a simple problem, it is a simple figure, we need not to use the mathematical expression for convolution every time. Just by observing also we can find out. Now how to do that? Keeping x2t as fixed, time revert and time shift x1t visually. So if I find x1 of t minus tau, then it will be something like this. Okay, this is a time reverse and time shifted figure for x1 of t minus tau. Suppose give the name of this to x2 of tau. Now, when my x1 of t minus tau inserted in x2 of tau, then I'll directly make a plot. First of all, the convolution of this will lie between 0 and 3. Okay, so 0 will be the starting point and 3 will be the finishing point. Why 0 and 3? Because the range of convolution will be from sum of lower limit to sum of upper limit. So sum of lower limit is 0 plus 0, sum of upper limit is 1 plus 2. Okay, so when my x1 of t minus tau is getting inserted in x1 of x2 of tau, then from 0 to 1 it is getting inserted into this. So when it is getting inserted, my magnitude will keep on rising, and this value will be 1. At one point when this is completely inserted in x2 of tau, at that time magnitude will remain constant. It will happen up to point 2. Okay. Then from 2 to 3, when this x1 of t minus tau is started leaving x2 of tau, then again the magnitude will keep on decreasing. So it will be just like a trapezium. Now I got trapezium because x1 of t and x2t are not same. But if x1 of t and x2 t, if time width of these two signal are same, then I will not get a trapezium, but I will get a triangular pulse. Okay. So this is one way of solving this problem. Let's see it once again. It is a simple convolution, but we have not gone into the mathematics of this. Directly by visualizing the figure itself, I can find the convolution. Okay. Now, just for understanding the concept, the convolution of ut with ut is equal to a ramp function. Okay. Why? Because two step function, they are extending from 0 to infinity. Okay. When I convolve each one of this, then the magnitude will be keep on rising, rising, rising. I'll get something like this. Okay. If they are defined, if they are finite, then definitely it will stop. But if they are not finite, then it will keep on rising. Okay. So this is one problem, finding the convolution. Generally, the simple problems are asked in the GATE exam regarding the convolution. Okay. From the topic of convolution. Again, one more problem. The convolution of x of t plus 5 with delta of t minus 7. This delta is impulse function. Four options are given: x of t minus 12, x of t minus 2, x of t plus 12, and d is x of t plus 2. Out of this we have to find what will be the value of convolution of this. So, solution of this. See, take any xt. Suppose this is your xt. Let this one, and this is some point. X of t plus 5 will be how much? It is nothing but shifting it by 5. Okay, this is x of t plus 5. Delta of t minus 7, somewhere like this. At 7th point I am having. So when I convolve this point, I need to understand the overall convolution where the ranges will lie. Okay. Again, use the principle, sum of the lower limit to sum of upper limit. Sum of the lower limit as such in this 7 plus 5. Sum of the upper limit is how much? Again, it has no value. So it will be x of t plus 5 convolved with delta of t minus 7 will become x of t minus 2. Okay. Plot will be from point to this point, 2 to 5. The thing, but simple addition. 7, 7 and 2. This point has come 7 plus minus 5. This point has come 7 plus minus 2. Okay. Sum of the lower limit plus sum of the upper limit. In delta t function there is upper limit and lower limit are same, and that is equal to 7. So we need to add 7 with both the points. Okay. This is one example for xt. It is true for any xt. Okay. Now, another question. A Laplace transform is given for any system. We need to find the impulse responses of this. So the question is to find the impulse response of a system whose Laplace transform is given as this. Find impulse response. Solution. HS is written somewhere like something like s square into s minus 2. I can write this as a product of two expression 1 upon s into s minus 2. So inverse Laplace transform of 1 over s square is t. Okay. Inverse Laplace transform of 1 over s minus 2 is e to the power 2t. Now to get ht, which is nothing but the inverse Laplace transform of full this expression, so I can write. Now again we have to make use of one property, which is multiplication in S domain goes to convolution in frequency domain. Okay. Laplace inverse of 1 by s square convolve with Laplace inverse of 1 by s minus 2. This will be equal to t convolve with e to the power 2t qt. So this is the impulse response of the system. Okay. Very easy. See, generally the problems which we are solving, they are based on the property of Laplace transform or Fourier transform or Z transform. Okay. Again, one more problem. This is a very interesting problem. A Fourier transform of a signal is given, and that Fourier transform is g of omega is 1 by omega square e to the power g omega minus j omega e to the power j omega minus 1. For this, my gt is shown like this. Now I have to find the Laplace transform for first one, g1t, which is this. Find the Laplace transform of g1t. Like this, there are 3 figures are there for which we have to find the Laplace transform. Okay. We need to find the Laplace transform of g1t, which is this. Okay. So if we see the relationship between g1t and gt, g1t is g of minus t. That means it is a time reverse expression for g1 gt. Okay. So the time reversal will cause a frequency reversal also. Okay. So my g1 of omega will be 1 by omega square e to the power minus j omega plus j omega e to the power minus j omega minus 1. Okay, this one will be my g1 omega. For second, there is again given g2t, where g2t is this expression, minus 1 to 1. Now if we looking at the expression, by looking at the figure of g2t, g2t is nothing but g1 of t plus 1. Okay. So use the time shifting property, we can find g2 of omega e to the power j omega 1 by omega square e to the power minus j omega plus j omega e to the power minus j omega minus 1. So that will become 1 by omega square 1 plus j omega minus e to the power j omega. Okay. So this is my g2t. Third figure was g3t, and that g3t is this. Minus 1 by 2 to 1 by 2 and to this one. Now how to write g3t in terms of g1, g2 or gt? Okay. So for this, if I shift my gt by half towards left, that means g of t minus 1 by 2. Okay, and if my shift, and if I add this with g1 of t plus 1 by 2, I will get the required expression g3t. Now in this we just need to write the Laplace transform of this, the Fourier transform of this, and add these two expressions to get the g3t. Okay, so this is the way of solving the problem. See, g of t minus 2 will be something like this. Plus g1 of t plus 1 by 2 is something like this. Add these two expressions, I will get this expression. Okay. Simple. So these are the problems, typical problems appeared in previous GATE exam from the topic of signal system.